Brian, what are we doing?
Measuring spray angle on an unknown nozzle.
Unknown nozzle.
Yep.
Australia. Customer application. This is a company called Sloan Diesel in Australia. They sent them to us, asked us to AFM them. Apparently it's a marine nozzle from some other application in Australia. And basically what they're asking us for is more flow. So it's a VCO. It's still a P-size nozzle. The needle valve is DLC coated. We have our P570 blanks, which we can make into whatever we want to get these guys something a little bit different. And whenever you ship things from Australia to the US and US to Australia, it's not very cheap. So basically what I'm looking for is an alternative. Instead of them buying this nozzle from the OEM, shipping us this, paying tariffs and what have you and freight, and then us modifying it, charging them, shipping it back, and then paying tariffs and freight again. I'm looking for a better alternative. So what we've found so far, and we'll show you in just a second, is this is a 9-hole nozzle, and our hole size was like 0.00545 to...
Yeah, it was like 4.8-ish, somewhere in there.
Measuring hole size, 4.5 to almost 5,007 inch.
Yep.
9 holes.
9 holes.
That term isn't something you would normally say when you're speaking about performance application. The atomization is going to be really, really, really fine. You're not going to get a lot of penetration into the pocket. And since this thing is advertised at 155 degrees of spray angle, we take that with a grain of salt.
Yes.
We measure that.
Yes.
So, Brian, I would like you to show me and the camera how it is we go about measuring spray angle. And Morgan, if you want to come over and watch this process, let's do this. A little bit different camera angle shot, trying to show you guys exactly what it is we're doing. So again, we've got these nozzles that we don't know very well. They're labeled at 155 degree spray angle, and they're supposed to be equal on both sides. So we're going to measure one hole, we're going to roll it over, and we're going to measure 180 out. Now, if this is truthfully a 155, when you measure from right here to right there, we should see 77.5 degrees of angle differential, right?
Yep.
Can you please show us how we go about doing that?
Absolutely.
Thank you. So Brian, you've already taken you got about half dozen measurements right there already?
Yep.
And you've dropped lines on this and this?
Yep.
And this?
And up above as well. So you take an average of both sides.
Yep.
And that gets us where we need to be.
So this is the bottom profile of the nozzle laid out.
Yep.
And you also were up there on the top and
Yep.
you measured that as well?
Correct.
So that would be 2 parallel lines.
Yep.
And that's both sides of the nozzle.
Yep.
Now, you've also measured a parallel line on this side of your needle.
Yep.
And this side of your needle.
Yep.
And that is actually something that you stuffed in that little tiny hole, and it's just showing you angle of that spray angle, of that spray orifice.
Correct.
Okay. So what size piece of wire is that you've got shoved in that hole?
It's a 4 thou.
4 thou piece of wire. And it's very difficult to shove a 4 thou wire in, but when we measured it using the Starrett, we actually got about a 4.5 to a 4.8.
Yes.
So 4 thou, lots of friction on there?
Yeah, it's hard. Like I bent one and had to cut it.
Okay.
Hence the jeweler's glass, because I can't see that good.
No.
So we measured it. Now I'm going to set the angle. And so right now it's giving us an angle that would be based off of this. So that doesn't, yeah, off of that plane, that doesn't do us any good. I need one going off of this plane, because that will correlate into what I set into the machine.
Yeah.
So I just rotate this 76.5. That's 153 degrees.
So they're labeled at 155 degrees.
Yep.
Actual precision measuring, we got 76.5, not 77.5.
Correct.
So this is 153 degree. Now this customer is taking an application from a marine application nozzle in Australia that he found.
Yep.
And he's putting them in a different motor.
Yep.
So I know that he's got 9 holes.
Yep.
and he's got, can you do me a favor?
Yeah.
Can you, now that we've showed you guys how it is we're measuring the spray angle, can you pull the pin, can you roll the nozzle over and show them how it is that we go about measuring the spray holes, please?
No, the diameter?
Diameter of the holes, yep.
Yeah, I can do that. Okay, so we've got a spray hole here, and it's not very round.
That hole is not very round.
But so we're going to measure it anyways, and we can actually tell how far out of round it is if it will pick it up.
Okay guys, so what it's doing is it's throwing digital dots on top of what we're focusing it to see. And basically, what do you got?
About a 4.5 thou hole.
0046, and out of round by 0003. Roll it over another one just so we can show folks. Now when you're doing EDM here, we have one stick of wire, and as it burns a hole, the machine CNC spins the nozzle, and it uses the same wire to burn the next hole, spins it, uses the same wire. Our holes are going to be within about 50 millionths of 1 inch of each other. There are other EDMs on the planet that work faster, and basically you would have a stick of wire here, 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 and in an assembly line kind of formation, your nozzle would get moved from one area down the assembly line to the next, down to the next, down to the next, and if those EDM wires aren't exactly the same, those holes will not be exactly the same. Ours are slower, but ours are really, really, really accurate, so that's just why we chose to do it that way. What do you got here? A 0043. 3/10, almost a half a thou difference, which is basically about 20 or 25% when you're only talking about a 4 thou hole.
Exactly.
So we've got like a 20% difference from one hole to the next hole. This one looks a lot more round, or
It is.
even to the eye.
It's, I'll delete it so we can get the,
0001.
yeah, it was 0001.
So he's going to drop dots on that right now. .0045 thou with 0002 out of roundness. That's a nice hole.
That's a good hole.
You can visually tell that that's a really nice hole.
Yep, that one is better than the other one was.
Okay, so we've shown people what we're doing on this microscope. Let's use the other Boroscope real quick just so we can show them what it is that we see on the inside.
Okay.
So break the cameras for just a second, reset up, and move you on to the next process. All right, guys. So now, Brian, we've got the Boroscope.
Yep.
Basically, it's about a 5-inch long glass tube with magnification shoved in it, hooked up to a desktop, into a TV monitor. Can you please show us what it is that fuel sees before it sprays out the orifices?
Okay. So I've got a pin in here just to give you an idea. It's the same one we just measured the spray angle with, so it's a 4 thou diameter pin.
And we can physically see that that pin right there is 4 thousandths of 1 inch.
Yep.
Now you've got that shoved through that hole, and we can plainly see that the hole is bigger than the 4 thou right there.
Yep.
But we're also seeing that right here we've got a really shiny mirror-like surface.
Yep.
And that's because the OEM either used a process called sonoplast or possibly AFM or extrude hone. So we've already started to see some beveling there and some radiusing, and it's cleaned it up. So what we're going to do for this customer, per his request, is we're simply going to bump that flow rate up a little bit. They wanted like 30%. We're going to go about 2 liters of air per minute. But one of the key things that I have to assume that this is a very small cubic inch motor with a very small piston bowl, because we've got a very unique number of holes.
9.
9.
There's not very many nozzles out there with 9.
We don't see that in America hardly ever. Can you think of one?
Honestly, I think one of the Duramaxes has 8, and that's about as big as.
Well, the Cummins 0304 has 8.
Yep.
I don't think there's any 9. Not that I've seen.
No, I'm not the.
But genuinely, 1, 2, 3, 4, 5, 6, 7, 8, 9 spray holes. Now, since what this guy's trying to do is create more horsepower, what I'm going to offer is, number one, I want him to tell me exactly what the factory spray angle of the genuine application was. I know that what he's substituting is basically 153, 154 degrees of spray angle.
Yep.
But we don't know if that's even close to what the application he's trying to feed is. He might be using these things just because it was the closest thing to what he could get.
Exactly.
So we're gonna offer to find out what the actual spray angle should be. And then we're gonna offer to make this in a 7 hole, because 7 larger holes will penetrate into, they're gonna go a further distance before it starts to ignite and burn its way back to the tip. Meaning that if there is a piston bowl, then, do we got a piston bowl here real quick? Brian will grab us a piston bowl real quick, and we'll be right back. Okay, so trying to explain this to you so it's touch it, feel it, smell it, see it, and everybody can understand it. You've got a piston out of an 03, 04, 235 to 305 horsepower Cummins 5.9.
Yep.
And the bowl diameter going from the center out is not very much.
Nope.
We can physically see that going from center out, I've got a further distance to travel, right?
Yeah.
Now, this was the Cummins 8-hole application, and they don't need to go very far before they get all of the opportunity or oxygen available. I would need to travel a further distance before ignition, because if I start to burn at the same distance as that, then I'm leaving all the oxygen outside of that flame front unburnt, which means that I'm leaving opportunity for power and cleanliness on the table. So since this is kind of a hybrid application and we don't necessarily know the motor that he's working on, I've got questions to ask him. What is the OE spray hole count? What is the OE spray angle? And we'll make him something custom to make him something better than what he is probably gonna get if we just AFM these up. He's already sent the parts here, so we'll go ahead and AFM those for him, and I'm sure he'll take care and sell those. But in the future, like if I can make his job better and make his customers happier, by all means, I'm gonna do that. So I hope this kind of clears up what we were trying to say.
Yeah.
Because we've seen this a million times.
I would like to add something.
Sure.
So if you're filling out a race waiver to have a custom set of nozzles or injectors made, we really need accurate information on what piston you have. So I'm sitting on an order right now because we're not sure. I'm not going to make them. I can't get a straight answer out of the guy. I would just as soon not make something and not sell it than make something and blow a motor up or have really poor performance. So please, we need the right info.
Yeah, without proper info, guys, like all the money that we've spent on machines, all the money that we've spent on trying to learn how to do things properly, if we don't have really good information, we can't kick really good parts out. So in that application, what questions do you have for the guy that you need to get answered?
What piston is in this engine? It's a custom piston that he's had made. He doesn't have hardly any information on it. We've looked at it. We don't even have a picture of what the piston looks like to go off of. So it's going in a mechanical truck. I have an idea what it is, but I'm not sure. I'm not going to make them until I know for sure.
Guys, we cannot make parts guessing, because we might make really good holes, but if they're aimed at the wrong thing, it's not going to run right, and we're probably going to melt a piston. So it's very important that you, the consumer, if you're going to get this stuff built, either send us a nozzle for us to reverse engineer, or send us like an actual data file of what the piston is, what it came out of, and if we don't know that piston, we're probably going to need to get bowl dimensions, diameters, and pocket depth, things like that, so we can actually make you the right parts.
Absolutely.
So, well, keeping it short, keeping it sweet. Brian's got a Snickers bar and a Monster to drink and eat over there, so I'll let you get back to it, but thanks for your time today, Brian.
Oh, you're welcome.
All right, buddy. See you guys.